Section 4.7, Financial Models. Suppose you put money into an interest-bearing account. The bank or the credit card company or whatever you're dealing with is going to calculate a percentage of the current amount and then add that into your account at certain points throughout the year. Well, this is what interest. And the deal is that's basically free money. Once they put that interest back into your account, the next time that they calculate your interest again, they're actually building interest off of the interest that you already gained. This is called compounded. So you're gaining money off the money that you received. Now, but watch out, because this is exactly what happens when you deal with loans or credit cards. Student loans are a big example. So they're going to charge you on that same amount. That is, they take a percentage, they charge you, they put it into the original principal, and then they build the interest off of that new amount. And so compound interest exists a lot of places. Our formula for compound interest is as follows. Now, A is going to be the current amount that is in the account. P is going to be the principal amount. That is the original deposit or loan, depending upon if you're borrowing or loaning. R is an interest rate, and it always needs to be in decimal form. If you try to use the calculation with a percentage, that's not going to work. And just as a side note, the percent symbol literally means per 100 or 1 over 100. And so make sure you realize that you must work with decimals when you're dealing with interest rates. T in this formula is going to be time, and it always needs to be in years. Must be in terms of years. N is going to be the number of times that they compound the interest. That is, the number of times they push the interest into the principal, and then the next time they calculate the interest, they'll calculate it off of the new principal. And in general, some terms you'll probably see. Annually means they're just going to compound it once a year. Semi-annually, we're going to take that to mean 2. Quarterly, 4 times a year. Monthly, 12 times a year. Weekly, 52 times a year. And daily is going to be 365 times in a year. It's also possible that you deal with a continuously compounded interest. That is, at every moment in time, the interest that it built the moment before gets added immediately into your principal. And that formula is going to be A is equal to P times E to the RT, where E is our natural number E. Well, A is still going to represent our current amount in the account. P is going to be that initial deposit or loan amount. R is going to be your interest rate in decimal form. T must be time in years. And so anytime they talk about continually increasing or decreasing, you're going to use E as part of that function. So you invest $4,000 in an account with an interest rate of 4%, compounded quarterly. How much money is in the account at the end of 20.5 years? First things first, our formula, we see it's not continuous, so the amount in the account is going to be equal to P times 1 plus R over N raised to the NT. So then we just need to identify all the parts of this formula. Well, you invest $4,000, that's our principal. There's an interest rate of 4%, that means that R is going to be equal to, remember 4% really means 4 times 1 over 100, which means that this is going to be 0.04. That's our rate. Compounded quarterly, that tells us that N is equal to 4. Then they tell us 20.5 years, so T is equal to 20.5 or 20.5. Then it's just a calculation. The amount after that period of time is going to be the principal, 4,000, times 1 plus the rate, which was 0.04, divided by N, which is quarterly, so 4, raised to the N, which again is 4, times T, which is 20.5. At this point, it's just calculator value. I get that this is 4,000 times 1.01, raised to the 4 times 20.5 is 82, raised to the 82nd. Well, it's rounded 2 decimal places since we're talking about money, so I claim that this is then $9,045.08. And that's how much money would be in the account after that amount of time. You invest $100 in an account with an interest rate of 6%, compounded continuously. How much money is in the account at the end of 8 years? Continuously meaning A is equal to P times E to the R times T. So our amount, A, is equal to, we see that our principal is 100, our rate is 6% or 0.06, and our time is 8 years, and so that's going to be 100 times e raised to the 0.06 times 8, which I get that to be 100 times e raised to the 0.48. I get that to be approximately $161.61. So let's say your goal is to have $5,500 in an account that offers an interest rate of 4% and is compounded monthly after 10 years. How much should you initially invest? Okay, so let's talk about what we have. So they tell us that this is the amount of money in the bank after a time of 10 years where our rate is 0.04. Well, since our formula was A is equal to P times 1 plus R over N raised to the NT, plug in what we have, and then we probably have an equation we need to solve. So that is 5,500 is equal to, we don't know the principal, times 1 plus R is 0.04 divided by compounded monthly means N is 12 raised to the 12 times 10 pounds. Alright, so now we need to solve this. Well, we're just solving for P. I get that this is P times approximately 1.491. You need to round to at least 2 decimal places, otherwise your calculations are going to be off. So then we just need to solve for P, so I'm going to divide 5,500 by that number. Then I get that P is equal to $3,689.21. Now let's find the principal needed to get $90 after 3 3/4 years at 3% compounded continuously. Well, since our formula is A is equal to P times E raised to the RT, we know that we need to get an amount of $90, and we don't know the principal, that's what we're looking for, times E raised to the R, which is 0.03, there's our rate, and times our time, which is 3 3/4, or 3.75. So I get that this is 90 is equal to P times E raised to the 0.1125. Now I'm going to divide by E to the 0.1125, and I get that P is approximately $80.42. So what interest rate would be needed on an account compounded annually to double an investment after 30 years? And then we want to know triple that investment. Okay, so what in the world does that mean? Well, first off, so then our formula is going to be A is equal to P times 1 plus R over N raised to the N times T. Now the fact that they say double the investment after 30 years, well, that means that my amount could really be what? That really could be 2 times the principal. Alright, so let's deal with it like that. Double the investment is 2P is the amount, and then that's going to be equal to the principal that we don't know, times 1 plus the rate that we don't know, divided by N equal to 1, raised to the 1 times 30 years. Alright, great. Now let's look at what we have. Well, we've got this 2P is equal to P times 1 plus R to the 30. Alright, so let's clean it up a little. Then let's divide both sides by P. And the reason I can divide by P is because if I'm investing money, it won't be $0. And so it doesn't make sense for it to be 0. It has to be a number non-zero, so division by P is perfectly fine. At this point, I get that 2 is equal to 1 plus R raised to the 30th power. Well then, how do we solve this? Well, this is the 30th power, so we just need to take the 30th root. The 30th root of 2 is about 1.02337, and then that's equal to 1 plus R. Now technically you got to deal with the plus minus, but we're not going to have a negative interest rate, and so we're going to leave it be. Then subtract 1, we get that R is approximately 0.02337, and so depending upon how you want to write, that's the same thing as 2.34%. So that's double. Well, we're going to do the exact same thing for tripling, but now instead of our amount being 2P, our amount's going to be 3P. So that's 3P is equal to P times 1 plus R to the 30th, because that's the only thing that's changing here, is that we're tripling our investment. Our rate is the next question. So then divide both sides by p again. You get 3 is equal to 1 plus r raised to the 30th power. Take the 30th root, and I get that that's approximately 1.0373, which is then equal to 1 plus r minus 1 minus 1. I get that r is approximately 0.0373, or in percent form, that is 3.73%. That's the rate we would need for this amount to triple after 30 years. I have $500 to invest at 7.5% per annum compounded monthly. How long will it be before I have $750? All right, so we want to know, given the amount that we need is $750. So 750 is then equal to P, the principal, that's that $500 there, times 1 plus our rate, which is 0.075, divided by N, which is the compounded amount, and it's compounded monthly, so that N is 12, raised to the 12t power, because we want to know how long it will take. So we do have an exponential here, but we need to get to it. So let's first divide by 500, divide by 500. That's 1.5 is equal to 1.00625 raised to the 12t power. So what can we do at this point? Well, we can take a logarithm. And let's not do a weird one, let's just take the natural log. Why not? You could use log base 10, it would be equivalent. Take the natural log of both sides. Then I have that this is the natural log of 1.5 is equal to the natural log of 1.00625 raised to the 12t, but because this is raised to the 12t, I can put it out front, and so that's 12t times the natural log of 1.00625. At this point, divide by 12 times the natural log of 1.00625. So then I get that t is equal to the natural log of 1.5 divided by 12 times the natural log of 1.00625. And what do I get? Then I get that the time that it would take to reach that amount is approximately 5.4 years. But now we need to figure out what would happen if it was compounded continuously. So everything's the same except that the formula we're going to use is the continuously compounding interest. And so that's going to be 750 is equal to 500 times e raised to the 0.075 times t. Process is identical. Isolate your exponential function. Divide both sides by 500. We then get that 1.5 is equal to e to the 0.075t. Now I take the natural log of both sides. But when I take the natural log of both sides, then I get that this is the natural log of 1.5 is equal to, well, 0.075t comes out front of the natural log, and then natural log of e is 1. This is then 0.075t. Divide both sides by 0.075, and we're going to get that t is equal to the natural log of 1.5 divided by 0.075, which I get is approximately 5.4 as well. Now it does end up being slightly less. If you check that calculation, you'll see that it actually takes a little bit less time, but not much. You buy a house for $190,000. The expected appreciation rate is 7% compounded annually. How much will your home be worth in 5 years? So we want to know what its value is. Well, appreciation just means that it's going to grow in worth, and so we have a rate of 7%. We have a principal of $190,000, and we have compounded annually, so n is 1. We also have that t is equal to 5. And so then after 5 years, we can calculate that this is going to be worth $190,000 times 1 plus 0.07 divided by 1 raised to the 5 times 1 power. Then I get that this is 190,000 times 1.07 raised to the 5th power, which I get to be approximately $266,484.83. You're planning to buy a $15,000 car when you graduate from college in 3 years. How much should you put in an account that pays 6% interest compounded continuously so that you will have enough in 3 years? So we know that the amount that we need is $15,000. The time that it needs to be in there is 3 years. It pays 6% interest, so R is equal to 0.06. Compounded continuously means we use the compounded continuously formula, and T is 3. Then this is $15,000 is equal to the principal, which we don't know, times E raised to the 0.06 times those 3 years. Then to clean it up just a little bit, this is $15,000 is equal to P times E to the 0.18. So I'm just going to divide by E to the 0.18 on both sides. Then I get that P is approximately $12,529.05.